Okay, today we're going to be going over 7.2 on midpoint and distance formula. Our learning target, I can find the midpoint of a segment and the distance between 2 points. Okay, so let's start with distance. It says let's remember how to find the distance along a number line. We can simply count the number of spaces between our 2 points. Like if I start down here and I go 1, 2, 3, 4, 5, 6, 7, 8, and I go all the way to my next point. Or we can subtract our coordinates. Okay, so it says over here, x2 minus x1. What that means is if I come down here and here's my first point right here, and I go, okay, I'm going to label this one x1, and then here's my second point, so I'm going to label that one x2, and I take my value at x2, this is at 17 right here, and then I subtract it from x1, which is at -8 right now. So if I take 17, subtract -8, that will give me 25, which is the same thing I'll get if I count up all of my squares here. Okay, so we can take our coordinates and subtract them from one another and get our total distance. So moving on to the two-dimensional plane, it's easy to find the distance between 2 points that have the same x or y's. We can just subtract the x or y's in the same way. Okay, so let's take a look at example A. If we notice, our y values are both 4, right? Our y isn't changing. What is changing is our x values. Okay, so if I take my x values, and I'll start with 3 because that's my bigger number, and I subtract my -4, then I'm going to get 7 as my distance, which is the exact same thing as if I were to come here and see how many squares I have. I have 1, 2, 3, 4, 5, 6, 7. Okay, perfect. Then on this next one, we've got a vertical line. Okay, now we notice that our x's are the exact same. So what's changing is our y's. So I'm going to take my bigger y, my 9, and I'm going to subtract my 3 from it. That gives me a distance of 6. Okay, so it's really easy when we got straight lines on either the x or the y plane. But what happens when it's not on, they don't have the same x's or same y's, like this one down here. Now we've got to do a little something different. Okay, so the way we're going to do this, the easiest way is using Pythagorean's theorem. Okay, so Pythagorean's theorem is a squared plus b squared equals c squared, right? But in order to use this, we actually need a triangle. So I'm going to come down here and I'm going to make a triangle. Just like that, okay? Now I've got my triangle. Now I'm going to come through here and I'm going to say, okay, well, I've got 1, 2, 3, 4, 5, 6, 7. Okay. And then I've got 1, 2, 3, 4, 5. Okay. So these lengths I can count because they're just straight lines. Those are easy for me to count. But this diagonal, I'm not sure how long it is. So if we remember Pythagorean's theorem, we can call these two lines our legs, which is we can call A or B, right? Doesn't matter which one we call them, but I'm going to label this one A and this one B, and C is always my hypotenuse, okay? So now that I have everything labeled, I'm just going to plug these numbers into my equation. Well, A squared means 7 squared for this example, plus 5 squared is equal to C squared. Okay, well, 7 squared is 49, and 5 squared is 25. Still have a C squared. So if I add 49 plus 25, that gives me 74 equals C squared. And now all I have to do is get rid of my square. Okay, so I'm going to square root both sides. So that's going to give me the square root of 74 is equal to C. Now, if the square root of 74 simplifies, we would simplify that, but this doesn't. So that means that's going to be our final answer, or the distance of this line right here, is the square root of 74. Okay? So looking at it, that is our distance formula, okay? Down here on the left, that's the version we used. We used a squared plus b squared equals c squared, just like the Pythagorean theorem. This red formula, or the one that's shown over here, is the exact same thing as the Pythagorean theorem. But what it's saying is you need to find the distance of your x's. So you need to subtract these two to find your a. And you need to subtract your y's, or these 2 points, to find your b. Okay, but that's the same thing. I could have subtracted in the last example, but instead I counted. Okay, we could also subtract, but this distance formula is going to come into play when we don't have a grid system. When we have a grid like the last one, it's super easy just to count up those lines and then figure it out using the Pythagorean theorem. But when we don't and we're only given points, then this distance formula is going to come into play. Okay, so let's take a look at some examples. It says find the distance between the 2 points. Okay, just like before. So what I'm trying to find is this distance right, that's not a straight line, this distance right here, okay? So I'm gonna do the same thing as before. I'm gonna make my right triangle, okay? And then I'm just gonna count up how much I have on each side. Well, on the bottom here, I've got a distance of 3 squares. And then on the left side, I've got 7 squares, okay? And now I've got a problem that looks very similar to the one we did on the last page. But instead of going through and labeling each one of these and rearranging the formula, if I look up here, I can actually just plug it right into this equation right here. C equals the square root of a squared plus b squared. If I plug it in just like that, so my C, which is what I'm looking for, is equal to the square root of 7 squared plus 3 squared, okay? And if I plug that into my calculator just as is, it will give me my answer. My answer is the square root of 58. That's as simple as that one will go, so that's our final answer. Okay, now we have the exact same thing going on over here. I'm going to draw my triangle, okay? And now I'm going to count up how many squares. Well, I've got 3 down here and 3 over here. So I'm looking for C. C is equal to, same formula, the square root of a squared, 3 in this case, plus b squared, which is also 3. Okay, and if I plug that into my calculator, it will give me 3 square roots of 2 as my simplest answer. Okay, and the reason I'm leaving these in radical form rather than decimals is because right here it's saying leave it in radical form. Okay. Okay, now E. It says find the distance between the 2 points in the simplest radical form. Okay, now we don't have a nice grid like we did in the last few examples. So now this is where the distance formula is going to come into play, and I copied it down here so we could see it more easily. So what I always do when I come to a problem like this is I remember that a ordered pair is x comma y, okay? X comma y. So now I'm going to go through and I'm going to label each one of my ordered pairs. Well, this is my first x, so I'm going to say x sub 1. This is my second, or my first y, excuse me. And this is my second x, and this is my second y. So it's always xy, xy, and I labeled the first coordinate x1 and the second coordinate x2. Now I have labeled them to match exactly what it wants in my distance formula. So all I have to do is say my distance is equal to the square root, and then I do a parenthesis. It says x2, my x2 is -3, So -3 minus x1, which is -5 in this case, close parenthesis and square it, plus open parenthesis y2 is 1 in this case, minus y1, which is 8 in this case, close parenthesis and square. So I can plug that directly into my calculator, or I can simplify a little bit. I'm just going to simplify just to make it a little easier to plug in my calculator. If I simplify this down, I get -3 minus a -5 is 2 squared, plus 1 minus 8 is -7 squared. Okay, now I'm going to plug that directly into my calculator, and I get the square root of 53 as my final answer. Okay, so it's more or less the same. There's a little more to plug in, but it should look familiar because it's the exact same thing. This is our A and this is our B here, okay? So now going on to the next example, I'm going to do the exact same thing. I'm going to come over here. I'm going to say this is x1, this is y1. This is x2, this is y2. Okay, and now I've labeled everything I need and I can plug it directly into the formula. So I've got my distance is equal to x2, well, the square root first, sorry, and then x2, which is -7, minus x1, which is -1, squared, plus y2, which is -6, minus y1, which is 2. Let me square that. Okay, so -7 minus -1 gives me -6 squared, plus -6 minus 2 is -8 squared. Okay, and if I plug that into my calculator, I get 10, which is my final answer. Okay, so that's it with distance. Okay, that's how you find your distance. You either plug it into the distance formula or you use Pythagorean theorem. Whichever easier, whichever situation you're in, or whichever you prefer. Okay, now let's talk about midpoint. So midpoint is also pretty simple because it also has a nice little equation for us to follow. So if we're trying to find the midpoint of the same line from earlier, what we do is we take our two given points and we use this formula to find it. So what we're doing is for our x, we're adding our two x's together and dividing by 2, and then we add our two y's together and divide by 2. So looking at this example, I've got the points -3, 4, and the point 2, -3. Okay, so I'm going to come through just like before. This is x1, this is y1, this is x2, and this is y2. So I'm going to add my two x's together. I'm going to have a parenthesis, and then my x1 is -3, my x2 is 2, and I'm going to divide that by 2. Then I'm going to add my y's together, so 4 plus -3, and divide by 2. Okay, well, -3 plus 2 is -1 over 2. So I've got -1 over 2, comma, and then 4 plus -3 is 1 over 2. So 1 over 2. Okay, so my midpoint is at -1/2, 1/2. So that looks like, if I come over here on the graph, it's right somewhere here. That's the middle of that line right there. Okay. And that's all midpoint is. We're just finding where the middle of the line is. Okay. Let's look at some examples. So find the midpoint of the segment using the following points. Well, I'm going to label this x1, y1, x2, y2. Then I'm just going to plug it into my formula. I've got my parenthesis, my two x's, so -3 plus 3 divided by 2, comma, my two y's, 6 plus 0 over 2. Okay, -3 plus 3 is 0. 0 divided by 2 is still 0. So I've got 0, comma, 6 plus 0 is 6, and 6 divided by 2 is 3. So the point for that, for my midpoint, is 0, 3. Okay, let's do this other example here. x1, y1, x2, y2. Okay, same thing. I'm just plugging it into this formula right here. So my two x's added together. So I've got 7 plus 4 divided by 2, and my two y's added together. So I've got -6 plus -10 divided by 2. Okay, 7 plus 4 is 11, and 11 divided by 2 doesn't simplify, so I'm just going to leave it as 11 over 2. And then -6 plus -10 is -16. -16 divided by 2 is -8. So my ordered pair is 11 halves and -8. Okay, now it says we've got a line AB, and the midpoint of that line is M. Okay, it gives us the coordinates for M, and it gives us the coordinates for A. What are the coordinates for B? Okay, so let's draw this out. I think that's going to be useful. So I'm going to draw a line here, okay? And my line is AB, okay? And then the middle of this line is my point M. Okay, well, M is located at -4, 0. And A is located at -6, 6. And what I'm trying to find are what are the coordinates for B down here. Okay. Well, if I'm gonna think of this one at a time. Okay. So I start at -6, and if I go to the middle of my line, I end up at -4. So I have to think, what did I do to go from -6 to -4? Well, what I did was I added 2. And if I added 2 to get to the middle of my line, to get to the end of my line, I just have to do the exact same thing and add 2. Okay, so if we think about this, I have -4, and I'm going to add 2 to it. -4 plus 2 is -2. So that right there is going to be my x coordinate for my answer, -2. Now I'm going to do the exact same thing, but with my y's, okay? I'm starting at 6, and I went to 0. So if I started at 6 and I go to 0, I'm really subtracting 6. And if I subtracted 6 to get halfway there, I've got to subtract another 6 to go the other half. So I've got 0, subtract 6, that gives me -6. So the other coordinate here is a -6. So the point B is located at -2, -6. And that's all it's asking for. Now J is just like I, but we're actually going to skip this one. And we're going to go ahead and start working on our delta math.